2.6 objectives. Number 1, find the domain. Number 2, combine functions using the algebra of functions, specifying the domain. Number 3, form composite functions. Number 4, determine domains for composite functions. And number 5, write functions as compositions. So first of all, let's talk about domains. Okay? So any function that I give you, you should be able to give me the domain, right? So what if I say f of x equals x squared minus 7x? What's the domain of this function? Oh, what shape is it? Parabola. What's the domain of a parabola? All real. How would you have to write it if you were writing in an interval notation? You guys kind of sound like a robot. Okay. What about this? F of x equals 1 over x plus 5. What's the domain here? All reals except negative 5. How do you know it can't be negative 5? Oh, you set the denominator equal to 0 and solve that? Okay. So how would you write that in interval notation? To negative 5, right? Union. And then on the other, it's not unity, guys. It's union. Unity means something different. All the way to infinity, yeah? What about this one? F of x equals the square root of 3x plus 12. So here we had to do something because the denominator is not allowed to equal 0, right? What do we have to do here? Is this allowed to equal 0? Yes. But what it can't be is less than 0, right? So here I had to, in my head, I had to say x plus 5 equals 0 and subtract 5 from both sides to say x equals negative 5, and I knew that's where it couldn't be, right? What do I have to do here? I have to make it less than 0 and solve it because that tells me where it's not, right? Or could I solve it to be greater than 0 because that's where it is? Does it matter? No, you just have to know about it, what's going on in your head, right? I would probably choose to make it greater than 0 because that's where I know it's going to be, since whatever's underneath that radical has to be greater than 0, right? So if I subtract 12 from both sides, I get 3x is greater than negative 12. And if I divide both sides by 3, I get x is greater than negative 4. Well, guess what I just found? The domain, x is greater than negative 4. What does that look like in interval notation? Can I ask you a quick question? Is it allowed to be or equal to? Is this allowed to be 0? Do you know the square root of 0? Yes, it's 0, right? So this is actually or equal to, isn't it? Okay? So this actually is negative infinity to negative 4, but negative 4 has a bracket, right? What about this? Still trying to find the domain. Don't I have to do the same thing here as I did up here? So set it equal to 0. X squared minus 2x minus 3 equals 0. What do I have to do? Ooh, factor x minus 3x plus 1. Right? Oh my gosh. Absolutely, Bella. Good job. Thank you, Bella. Good catch, babe. Good catch. If it makes you feel any better, I just taught this lesson at Harn-Simmons, and we were doing things that made it be on the left side, so that's why I was thinking of that. I apologize, though. Thank you for catching that. Very good catch, Bella. So what do I do with this? So x equals 3 and x equals negative 1. How do I write that as my domain? I could write all real numbers except negative 1 and 3, but might as well write it in interval notation because that's what you know you need anyways, right? So negative infinity to what? Negative 1, and then negative 1 to where? 3, and then 3 to infinity. Yeah. You guys are so funny. Okay? Combine functions using the algebra of functions. You ready? This is so hard. F of x equals 2x. G of x equals x minus 1. Those are given to you from the beginning. Okay? First thing you have to be able to do is find f plus g of x. What do you want me to do with those two functions? So 2x plus x minus 1. 3x minus 1. What's the domain of that function? Well, what shape is it? It's a line, so negative infinity to positive infinity. You see why it's so hard? Yeah, because it's not. Guess what's next? Minus. So 2x minus x minus 1. Doesn't that become 2x minus x plus 1? Which is what? X plus 1. What shape is that? A line. So what is the domain? Oh my goodness, y'all are so amazing. Guess what's next? So 2x times x minus 1. 2x squared minus 2x. What shape is that? Parabola. What's the domain? Oh, real. What's next? F over g of x. Done. What's the domain? Except for 1. So negative infinity to 1 and 1 to infinity, right? And how do we know that it was except for 1? Yeah. All right, second half of 2.6. Yesterday we talked about finding domain and combining functions. So finding the domain of a function, but also adding, subtracting, multiplying, dividing functions using the algebra of functions. And then we talked about finding the domain of that again. Today we need to talk about composition of functions and domains for composition of functions and writing functions as compositions. Okay, so it's like backwards of what we're about to do. Okay, so first of all, forming composite functions. Okay, so first of all, I'm going to tell you something like f and g. So I told you f of x equals 2x and g of x equals x minus 1. So what we're finding is this. F of g of x. Sometimes f of g of x, it's written both ways, but because it's written this way, sometimes we call this fog. That's not a zero, it's not a multiply, it's a composite. Okay, fog. So here's what we do. We start with f. Okay, we start with 2x, but instead of writing a 2x, I write g of x. See how I took, this used to say x and now it says g of x? So anywhere there was an x, I put in g of x. The only difference is I know g of x, which is x minus 1. So to find f of g of x, I'm going to distribute to get 2x minus 2. Now, to make sure we talk about the domain of this as well, I just think to myself, self, what shape is this? Yeah, it's a line, so it's the domain of a line. All reals. Okay? Now, what's interesting is that not only can you find fog, f of g of x, yeah, you absolutely can. You can find goff, or g of f of x. It's sometimes written like that, right? So this time we start with g. But anytime I get to an x, what am I writing instead? F of x minus 1. Well, except I know what f of x is, right? F of x is 2x. Okay, done. What's the domain of this? Yeah, because it's a line, right? Does that make sense? So what if the functions that you're given are a little bit more difficult? I started off easy on purpose. You cry, yes, and you get tissues from over here, right? Get tissues, okay? Always be prepared, like a Boy Scout. So what happens if f of x is x squared minus 6x plus 5, and g of x is x plus 2? It's just like it appeared and then disappeared and appeared again. That's weird. Sorry about that. Okay. So first let's find f of g of x. Okay, so I start with f, but anytime I get to an x, what do I write instead? G of x. So can we, like, how comfortable are we? Do you understand the idea of this? So do I need to write g of x, or can I just write g of x? Are you okay with that? So instead of writing g of x squared, I'm actually going to write what g of x is squared, right? Minus 6 times g of x plus 5. Anywhere there's an x, I got to write g of x. If you need to physically write g of x, do that, and then the next step you can substitute in what you know g of x is. Does that make sense? Okay. Now we just have to simplify, right? Okay, x squared plus 4x plus 4. Would you have gotten that right, or would you have written x squared plus 4? Good, because you did x plus 2 times x plus 2, right? And distributed. Yeah? I mean, it helps if you make the sounds. Yeah. Minus 6x minus 12 plus 5. Yes? Distributing here and here. Okay? So when I simplify that, I get x squared. I got a 4 and a negative 6. So minus 2x minus 3. 4, negative 8, and plus 5, so minus 3. Domain. What shape is this? Parabola, so the domain is? Yep, all reals. Okay. Can we find g of f of x? Perhaps. Start with g. Anytime I get it to an x, I write f of x, right? So f of x plus 2. So x squared minus 6x plus 7. And the domain? It is a parabola. Yeah, I know. Sometimes I can even be weird. What are you saying sometimes? You better shut up. Yeah, I did. That's fine. So, we kind of did 3 and 4 at the same time, right? Do the composite functions and then determine domains. You good with that? Now, write functions as compositions. Sometimes people think this is confusing until I show them how it goes. And then they want to do a lot of these because they are, yeah. Here is the function. I want you to write this as an f of x and a g of x. So if I did f of g of x, how would I get here? Okay, you ready? F of x is the cube root of x. And g of x is x squared plus 1. Right? Because if I did f of g of x, I would start with this and plug this in. Wouldn't that be that? Easy or hard? Okay, then you do this one. You do this one. Square root of x squared plus 5. What is f and what is g? Square root of x is f. Somebody else tell me what g is. Perfect. Got it? Now, would that be the same as if I ask you for g of f of x? It would not, would it? That would not be the same. They would actually have to be switched then, wouldn't they? Okay? But I specifically asked for f of g of x, and that's why we could get there easily. Okay? Any questions?